On CP3-1, we're going to learn the vocabulary of this unit, which includes the words circumcenters, incenters, and orthocenters. So the first word you need to know is concurrent, and that means they intersect at one point. So these three lines all meet at this point, so they are concurrent. You also should already know some different special lines within triangles. So remember, your altitude forms a 90-degree angle with the opposite side. Your median splits the opposite side in half. Your angle bisector splits your vertex angle in half. And your perpendicular bisector is kind of like a median plus an altitude, where it makes a 90-degree angle and it cuts your sides in half. Okay, it does not have to go through the vertex though. So if we draw in three angle bisectors, and I'm going to do this the best I can. If you were doing this for real, you would have to use a compass and a straight edge. But with my three angle bisectors, and again, I'm a little bit off, they all meet at one point. That means those are concurrent. And the point that they meet at is called the incenter. And there's some special properties with the incenter. So as we just said, the incenter is formed from angle bisectors. And it will be equidistant from the sides of that triangle. So if I have a triangle and I draw in my angle bisectors, what ends up happening is I get a circle where this is my center. So there's a circle inside. And because the radius is the same all the way around the circle, I know that the center of that circle, that incenter, is equidistant to each side. So it's in the center of a circle, the circle is inside the triangle, hence in center. It's equidistant to the sides. We use it when we want to place an object the same distance from three paths, roads, rivers, highways, hallways, whatever, anything that are lines. Now if I put in my perpendicular bisectors, so I'm going to cut this side in half and make it a 90-degree angle, more or less. And I'm going to cut this side in half, and I'm just eyeballing this, so it's not going to be perfect, and I'm going to draw in a 90-degree angle, and then I'm going to cut this side in half, and this is going to be far from perfect, but we'll just go with it. They also meet at one point. So the three perpendicular bisectors are also concurrent, and they're called the circumcenter. And with the circumcenter, I end up with a circle that goes through the vertices of each triangle with the circumcenter as the center. So it is the same distance to each vertex. So to review that, it is formed from perpendicular bisectors. It is equidistant from the vertex or vertices of the triangle. The circumcenter is the center of a circle that goes around the triangle because it's equidistant to each vertice. We're going to use it when we want to place an object that's the same distance from three towns, cities, trees, buildings, fountains, intersections, what have you. So sometimes, like high schools will do this. You'll have three towns, and they're all small, and they're on a map like this, and they're like, well, we want to share a high school because none of our towns are big enough that we each need one. Let's find where that circumcenter is, and let's build close to there. Now, if you have three all in a row, though, like this, you could make a teeny, or like nearly out in a row. Maybe this one's just a little bit out like that. So you've got a triangle like that. Well, if those are all on the circle, your circle is mostly out of it. So they're all driving a really long way to get there. So we don't always use this. Sometimes we're just like, you know what, it's just gonna have to be in one town and everyone else is gonna have to deal with it, and that's okay. But theoretically, if we wanted it to be equidistant from 3 places, we would find the circumcenter. All right, now if I drop in my altitude, so I go from the vertex, perpendicular to the opposite sides, those are also concurrent. And we call that point the orthocenter. So the orthocenter is formed from altitudes, but there's nothing special about it. If you grow up and you become an engineer or a city planner or what have you, and you're like, gee, I'm sitting in this meeting and I'm trying to remember what's that point that we need to use right now called, and your colleague says, oh, we need to find the orthocenter, you're going to be like, no, you're wrong. It's definitely not that one, okay? Because there's nothing special about it. We never ever use it. So, to summarize, you're using perpendicular bisectors to find the circumcenter. You'll get a picture that looks something like this, and it is equidistant to the vertices, to the points. Your incenter is made from angle bisectors. Its picture looks something like this, and it's equidistant to sides. And your orthocenter is made from altitudes. It looks something like this, but there are no special properties about it. One more quick note. In means inside. So an inscribed triangle means the triangle's on the inside. A circumscribed triangle means the triangle is on the outside. An inscribed circle would mean the circle's on the inside, because you've got that in. A circumscribed circle means the circle's on the outside.